Okay, so in this video, I'll focus on question number 7, and to be specific, question number 7A. Okay, this question is about cubic spline. Okay, so the question reads, given the data, f of 0 equal to 0, f of 1 equal to 1, and f of 2 equal to 2. Question says, construct, okay, the natural cubic spline that interpolates the data. Okay, so to find the spline that is going to interpolate the given data. Okay, so let's start. Okay, so we are on part A. I'm mainly focusing on part A, but in the other video, I also do part B. So we're given a f of naught, f naught equal to 0, and then f1 equal to 1, and f2 equal to 2. Okay, so now remember that the cubic spline, okay, let me just draw this first so that I can use for illustration. So that's the y-axis, you have the x-axis. So you have 3 points here, okay? You have 3 data points. Yeah, the point here at the origin, which is 0, 0, because when x go to 0, y is also go to 0. And then I have a point at 1, 1. Okay, let me just say that point 1, 1 is here. When x go to 1, y is equal to 1. And also have a point 2, 2. When x go to y is also equal to 2. So you notice that you have this spline here. Okay, so the first spline, from that point, they say this point A to point B. And then the other one, we join it from point B to point C. So I want to find the equation of each from point A to point B, as well as an equation from point B to point C. So we're going to have 2 splines. Okay, so the first spline, we call it S naught. Okay, so S naught of X, for cubic spline is given by A naught. Okay, these are the coefficients that we need to find. B naught, X minus X naught, plus C naught, X minus X naught squared, plus D naught, X minus X naught cubed. Okay, so that's the spline describing S naught. This is from A to B. Okay, and then the second spline is we join from B to C as S1 of X. So S1 of X will be equal to A1 plus B1 X minus X1, okay, plus C1 X minus X1 squared plus D1 X minus X1 cubed. Okay, so if you have 2 points in this case, if you have 3 points, for example, you have 3 points here, 1, 2, 3, you're going to have 2 splines, okay? You're going to have 2 splines, and the first spline here S naught is this one. The values of X are ranging between what? X naught and the X1. Okay, so our X1 is simply 0 here, our X1 is equal to 1. So the values of X in this interval will range from 0 to 1. And then for this S1 cubic spline, this one, the values of X will range from 1 to the last value of X is 2. Okay, now here is what we do next. So the next thing now is actually, as you can see, is to find the unknowns, and we have 8 unknowns in this case. So A naught, B naught, C naught, D naught, A1, B1, C1, D1, 8 of them. So we need to have at least, okay, or I say at most 8 equations we need to find. All right, so now the first condition here is okay, so the first condition we're going to look at is actually by evaluating the spline at each point. Okay, so we're going to evaluate this spline here, S naught. Remember that S naught is connected to 2 points, right? It's connected to A and also to B. So I'm going to evaluate S naught at point A and also at point B. So this will be S naught at point A, that is the X naught, right? Oh, and of course, let me just first simplify this, right? Our S naught is equal to, remember that our X naught is equal to 0, so this will just be A0 plus B0X plus C0 X squared, if you plug in for X naught equal to 0, plus D0 X cubed. Okay, while our S1, remember that our X1 is equal to 1. Okay, so S1 of X, this just be equal to A1 plus B1 X minus 1 plus C1 X minus 1 squared plus D1 X minus 1 cubed. And this one is in the set 1 to 2. This one in the interval. Okay. You have X values in the interval from 0 to 1. Okay, so now let's substitute. So let's now evaluate each spline at each point. So as I said earlier, that the first spline is common between point A and point B. So I evaluate the first spline at X naught at 0, right? Where X equal to 0. So this will be S of 0 equal to A0 plus B0 times 0 plus C0 times 0 squared plus D0 times 0 cubed. Okay, and this, remember that I'm giving it the input of X, it must give me the output of the function, and the output at 0 is also equal to 0. Okay, so from this, you can see that our A naught is equal to 0. So we found one unknown so far, so meaning that we have 7 unknowns to go. 7 unknowns to go. Okay, so next, the same spline, I'll evaluate this now at point B. Okay, so I'll say, okay, S naught of 1, because at point B, X is equal to 1. So S naught of 1 is equal to A naught plus B naught times 1 plus C naught times 1 squared plus D naught times 1 cubed. And this here, the output, when X is equal to 1, what's the output there? The output also is equal to what? 1. So we put this equal to 1. Okay. So that remember that our F naught is equal to 0. So just have B naught plus C naught plus D naught. And this is equal to 1. So I'll call this my first equation. Okay, so let me just even box it. So this is my first equation. Okay, so about the conditions, the first condition for equation 1 is done. The next, again, I also evaluate S1. So this spline from B to C now is in the same conditions as those for S naught. So I evaluate this at 1. So S1, evaluating this at 1. Okay. So the endpoint will be equal to A1 plus B1, 1 minus 1 plus C1, 1 minus 1. So I'm using the S1 equation, which is this here. Okay, so I'm just replacing where there's x, putting a 1 because I'm evaluating this at 1 plus d1, 1 minus 1 to the power 3. Of course, this will be squared here. And this is equal to, when you give it 1, you get a 1 for that point. X equal to 1, you give us output of 1. So we're getting this to 1, right? So all these will be just zeros. So you don't use that. Our A1 just be equal to 1. So from this, we found our A1. So we have 6 more unknowns to go. So 6 to go. Okay, so we found 2 unknowns so far. All right. And also, I also evaluate this at the end point, right? So this plane again, evaluating this at its end point there. So this is at 2. So S1 at 2. Okay. So this is S1 at 2 should be equal to, so A1 plus B1. This will be 2 minus 1 plus C1. Okay. This will be 2 minus 1 squared plus D1. 2 minus 1 cubed. And this is equal to the output when you have S, when X equal 2, again Y is equal to 2, right? So equal this equal to 2. So this just be A1 plus B1 plus C1 plus D1 equal to 2. And you already know A1 is equal to 1, right? So if you substitute, just have B1 plus C1 plus D1 equal to 1. So this is my second equation. Okay, so I can box it as well. Okay, so that is my second equation. Next, the next condition I'm going to look at condition number 2, which talks about the continuity of the function. So the function must be smooth. This means that the derivatives, okay, the derivative of the S naught at this point, the common point here must be equal to the derivative of S1 at the same common point here. So in simpler terms, we're going to equate the derivatives of these guys equal to each other because we're making sure that there's no jump here. The curve is smooth. Okay. So the derivative, okay, so I'm going to say the derivative of S naught, evaluating this at the common point happens at x is equal to 1. That's common point, must be equal to the derivative of S1 at the same point. Okay, so let's go ahead and find the derivative of each. First of all, we find the derivative of S naught, S prime of x. This gives me about S prime of x. Okay, this is what we have, right? S prime naught of x. So we're going to differentiate this one here. So you notice that A naught will go just made with B naught plus 2C naught x plus 3D naught x squared. So B naught plus 2C naught x plus 3D x squared. Okay, so now we evaluate this at 1. So this will be S naught prime. Evaluating this at 1, we have B naught plus 2C naught, you plug in 1 there, and then plus 3D naught. Also, let's find the derivative of the S1. So our S1 is this here. We get the derivative of A1 will disappear. Here you're just going to have B1. Okay, here you're going to have 2C1, and then x minus 1, 3D1, x minus 1 squared. Okay, so S1 prime. Okay, S1 prime of x is equal to B1 plus 2C1 x minus x naught is 1 plus 3D1 x minus 1 squared. Okay, and then we substitute this, we evaluate this at 1. It just be equal to B1 because this will be 0, plug in 1 here, and this will be equal to 0. Okay, so we equate these equal to each other now. So we're going to have B naught plus 2C naught plus 3D naught equal to 0, equal to B1. So B naught plus 2C naught plus 3D naught equal to B1. So this can also be rearranged as B naught plus 2C naught plus 3D naught equal to minus B1 equal to 0. So this is my equation number 3. Remember that we have found 2 unknowns so far, so remaining with 6 unknowns. Okay, so we have exhausted that condition. The next condition again is that if for the cubic spline, the second derivative at the common point also must be the same. Okay, so the first derivative must be the same as well as the second derivative must be the same. So let's get the second derivative of each. So S naught double prime of X is equal to, so I'm going to get the second derivative of this function here. So B naught will disappear, just have 2C naught plus 6D naught X. So 2C naught plus 6D naught of X. And then for the S1 double prime, so differentiate S1 for the second time. So B1 will disappear, here just have 2C1 plus 6D1. Okay, so we're going to have 2C1 plus 6D1 X minus 1. Okay, so this must be the same, evaluating this at a common point. Okay, S prime prime at the common point where X equal to 1 is equal to S1 double prime at the same point. Okay, so if we evaluate this 2C naught plus 6D naught times X equal to 1 equal to 2C1 plus 6D1 minus 1. So this term will be 0. So what we have, we just 2C naught plus 6D naught minus 2C1 equal to 0. So I have C naught plus 3D naught minus C1 equal to 0. So this is my equation number 4. Okay, so this is my second equation number 4 here. Okay, so remember that we have 6 unknowns so far, so we need to have at least 6 equations. So the next thing, the next condition now is the boundary condition. So the boundary condition says that the second derivative at the boundary, at the endpoints, must be equal to 0. So the second derivative of S naught at this endpoint and also at that endpoint must be equal to 0. So let's go ahead and do that. Okay. So the second derivative of that guy, okay, of S naught at that boundary condition must be equal to 0. Okay, so this is what we have, 2C naught at the boundary condition. Boundary condition is equal to 0, right? Okay, at 0, 0. So 2C naught, which is second derivative, we found it already, plus 6D naught times X equal to 0 at the boundary condition at the endpoint, right, of S naught. And at the endpoint of S naught, X is equal to 0. So 6D naught times 0, and this is equal to 0. So from this, you notice that our C naught is equal to 0. So we found our C naught. So we have how many unknowns to go? We say we have 5 unknowns to go. Now, since we found 4 equations, so it means that we need one more equation. So the other equation you're going to get is also the second derivative of the other function, spline at the endpoint must also be equal to 0. And we already found the second derivative of the other one as well. Okay, this guy here at the endpoint. The endpoint for this one is equal to 2, right? Remember that the endpoint is X equal to 2 for this. So 2C1. So I have 2C1 plus 6D x minus 1. So this is d1 must also equal to 0. So 2c1 plus 6d1. This is 2 minus 1. This must be equal to 0. So our 2c1 plus 6d1 equal to 0. So we can say that c1 plus 3d1 equal to 0. So this is our fifth equation. So now, since our 5 equations, 5 unknowns, we can go ahead and solve the equation. So let me just get all the equations together. Our first equation was b naught, c naught, d naught equal to 1. So these equations are b naught plus c naught plus d naught equal to 1. Equation number 2, we had b1, c1, d1 equal to 1. b1 plus c1 plus d1 equal to 1. And then the other one, we had b naught plus 2c naught plus 3d naught minus b1 equal to 0. Then the next one, we had c naught plus 3d naught. Let me just check if it's correct. Minus c1 equal to 0. Okay. And then the last one is just for finding here. c1 plus 3d1 equal to 0. c1 plus 3d1 equal to 0. Okay, now here we have 5 equations, 5 unknowns. So we can use Gauss elimination method to solve this here. So for Gauss elimination method, we're going to write this in matrix form. So here's the trick. Please let's write this in order, right? So arrange this in this order I'm telling you right now. So let's start with B naught, okay? And then what's the next note? Oh, so in fact, we can simplify this further, right? You notice that we found C naught. So C naught is not there anymore, because C naught found to be equal to 0. So this equation can be arranged as B naught plus D naught. Okay, B naught plus D naught equal to 1. And then here again also don't have C naught. Okay, so here gonna have B1 plus C. Gonna have B naught plus 3D naught. So this is just B naught. Where else do we have C naught? So again here we don't have C naught. So C naught is gone. We just have this guy here. Okay, so that's those are our new equations. Got? Okay. So we can now move. Okay, we can now move. So let's write this in matrix form. As I said, write this in this order. So we say B naught. Okay, next we have D naught. We're done. So we're going to have B1 as well. B1 have been found. C1 will be found. And D1 in that order. So let's form a matrix now. Okay, so for the first equation, do you have B naught? Yes, B naught, the coefficient is 1. D naught, again, the coefficient is 1. We don't have B1, so 0. We don't have C1, 0. We don't have D1, 0. And then this must be equal to the constant is 1. Okay, so that's for the first equation. For the second equation, we don't have B naught. We don't have D naught. Instead, we have what? B1, C1, and D1. So this will be 1, 1, 1, 1, 1, and the constant is equal to 1 as well. And the next equation, we don't have what? Okay, we have B naught, which is 1. We have C naught, which is 3. So D naught, which is 3. B1 is negative 1. Okay. And then C1 is not there. D1 is not there. And then everything equal to 0. Okay, and then here we have D naught. So B naught is not there. we just have D naught is 3, the coefficient. B1 is not there, C1 is -1. Okay, and then the rest are also zeros. Finally, we don't have B naught here, we don't have D naught here, we don't have B1. Okay, we only have C1 up to D1. So F1 and the 3, and this is equal to 0. Okay, so now this is the matrix I've formed. Say, okay, this is matrix for the 5 unknowns. Okay, so I formed what I call an augmented matrix. Okay, I'm just spreading this from the constants. Now I'm going to use the Gauss elimination method. So from the first row here, you notice that this is a non-zero number, so I can make this my pivot. So this will change the other rows. So which row is going to change here? So remember that if you make a pivot like this here, the numbers below that pivot must be 0. So this one is 0, so it means that you're not going to step that row 2. But this is not 0, you have to do something, right? For row 3, you have to do the operation. Row 4, no, you maintain it. Row 5, you're going to maintain it because you already have a 0 there. Okay, so I'm just going to change row 2. Row 3. So I'm going to write the operation for row 3. So row 3 becomes what? You can just subtract row 3 minus row 1, isn't it? So remember that the row that changes the other row is the row where the pivot is. So I'm just going to subtract the 2 rows so that I have 1, 1. So remember the itself doesn't change. 0, 0, 0, 1. And then this one, if you say this one, whether it's there with 0, so I'll just maintain the way it is. 1, 1, 1, 1. And then this one here, if you subtract the 2 rows, you're going to have a 0 here. You're going to have 3 minus 1, which is a 2. Okay, here you're going to have -1 minus 0, which is -1. Okay, and then 0 minus 0, you have a 0 here. 0 minus 0, you have a 0 here. And then you have 0 minus 1, you have a -1. Okay, and then the other rows still be the same. So this is 0, 3, 0, -1, 0, 0. And then you have 0, 0, 0, 1, 3, 0. Okay, so we have our new matrix here. Okay, remember that this is a V naught, D naught, okay, B1, C1, D1, and then we can separate this from the rest. Okay, now let's see, we go to row number 2. If you notice row number 2 here, we have to choose a pivot, right? So if you say this is a pivot cannot be an non-zero number, right? So we choose the one to be a pivot. But if we do that, make sure that all the numbers this side here are all zeros, right? All these guys must be zeros, but this is not the case. Okay, all the numbers to the left of this must be zeros, but this is not the case. We don't have zeros here. So that row doesn't qualify to be a what? A pivot, to have a pivot, that row. So I can interchange row 2 and row 3. Because if I interchange these two come and sit here, so it become a pivot. Okay, so I'll do the row interchange. So I'll say row 2 interchanging with row 3. Okay, so this is the row interchange I will performed. So I have 1, 1, 0, 0, 0, 1. Okay, so this will be 0, 2, -1, 0, 0, -1, and then this one will come here 0, 0, 1, 1, 1, 1, or the other two rows was to maintain 0, 0, and then here 0, 0, 0, 1, 3, 0. Okay. false. Okay, so now let's go ahead. So it means now this is a pivot we wanted. We'll introduce a pivot here, which is 2. So make sure that all the numbers below 2 are zeros. Okay, this is 0. This is not. We have to change this row number 4. Row number 4 has to change. While row 5 is to maintain. So I'll do the operation on row number 4. So how can I do that? So row number 4 becomes row number 4 minus the element itself divided by the element you have to change. You have to use changing the other, which is 2, right? The pivot element times row 2. So you notice that if you put 0 here, put 3 sorry here, it will be 3 minus 3 over 2. Row 2 is 2, so you end up having a 0. So you would have gotten rid of this 3 here. So let's see if after doing the operation here, what do we get? After doing the operation, what do we get? So the first elements are still the same as 1, 1, 0, 0, 0, 1, and then you have 0, 2. Remember the row where the pivot is doesn't change. 0, 0, negative 1. And then this one also will not change because it has a 0 below that pivot. So it is to maintain. Okay. And then finally, we are trying to change this row 4. So we have a 0 here. 3 will become a 0 after doing that operation. And then out of 0, 0 become what? So I have 0 minus 3 over 2 times row 2. So 0 minus 3 over 2 times element row 2, which is negative 1. So this just become what? 3 over 2. Okay, so we have 3 over 2 there as our new element in place of 0. Okay, similarly here, negative 1 minus 3 over 2 times element in row 2, which is 0. So just end up with negative 1. So that negative is to maintain. Okay, and then next you have 0, and then you have 0. I think everything just be 0 here. And then you have 0, here you have negative 1, that will be 3 over 2. Okay, so we are remaining with one more. Let me just not close this yet. Okay, and then the last row, remember nothing will change. Still have 0, 0, 0, 1, 3, 0. Okay, it's quite long though, but we're almost there. Okay, so now our next pivot will be in third row. Okay, that will be our next pivot, and that qualifies to be a pivot because all the numbers its left are equal to 0. Okay, so of course, so I'm going to use this row now to change the other rows below it. So this one here, you need to change, but row 5 will not change because the double is 0 here. So we just maintain it. So we have, we can write the row operation. So row 4, we're trying to change row 4. Row 4 becomes row 4 minus, okay, 3 over 2, row 3. So using row 3, we change row 4. So after doing that operation, what are we going to get? So this is 1, 1, 0, 0, 0, 1, 0, 2, negative 1, 0, 0, negative 1. Okay, or this one again, 0, 0, 1, 1, 1, 1. Now, okay, you are using, you want to change this 3 over 2, right? So that 3 over 2 now automatically becomes a 0 after doing that operation. And then you have negative 1, so negative 1 minus 3 over 2 times the element row 3, which is 1. So this becomes negative 5 over 2. So here we have negative 5 over 2. Instead of having 3 over 2, we have negative 5 over 2. And then here we have 0. Okay, 0 minus 3 over 2 times the element in row 3, which is just 1. Okay, so what do we have? We just have negative 3 over 2. Okay. And then here of 3 over 2 minus 3 over 2, what, row 1, right? Isn't it like this? So row 1 is equal to 0. So not row 1, row 3. Row 3 of element here. Oh, so it's equal to 1, of course. So I have 1 there. So this just be equal to 0. Okay. And then finally, this one here, we said we're not changing this, just to be the same. 1, 3, 0. Of course, I have to separate this, right? So sorry for this. This has to be separated there. Okay. All right. Now the next thing, we're almost there. So this now becomes our next pivot. Okay. So that is our next pivot. So we notice that we have to change this row 5. So we can write the operation again for row 5. Row 5 becomes row 5 minus what? 2 over 5. Okay. Times the row 4. Okay. So just divide 1, divide by magnitude of 5 over 2. So we have 2 over 5 there. And the signs are different, so we can use minus, right? When the signs are different. When they're the same, we use plus. So you can verify that if you put a 1 here, minus 2 over 5, row 4 is negative what? Oh, sorry, actually I have to use a plus here. Okay, so row 4 is simply negative 5 over 2 with a plus here. This and this will cancel out. Just going to have what? 1 minus 1, which is 0. So that's a row operation you're going to write there. Okay, so we need a plus there. Okay. So let's do that. So if we do that, this is a new matrix now we're going to get. It's very tiring. 1, 1, 0, 0, 0, 1. Okay, 0, 2, negative 1, 0, 0, negative 1. Okay. Okay. So we have 0, 2, negative 1, 0, 0, negative 1, and we have 0 here, 0, 1, 1, 1, 1, and then you have 0, 0, 0, negative 5 over 2, negative 3 over 2, okay, 0, and then finally here, what do we have here? 0, 0, 0. After doing the row operation, this also becomes 0. Okay, and then what does 3 become? So if we say 3 plus 2 over 5 times the element in row 4, which is negative 3 over 2. So what do you get there? Okay, plus 2 over 5 times the negative 3 over 2. So this is 4 over 5. And then out of 0, 0, to nothing changes there with 0. Okay. So this is now what you get as your final matrix. So you notice that I said this position here, this is the B naught, D naught, B1, C1, D1, right? Okay. So we start with D1. So we're going to have 4 over 5 D1 equal to 0. So our D1 will just be equal to 0. Okay, so for D1, and then negative 5 over 2 minus 3 over 2. Okay, sorry, negative 5 over 2, that will be C1. Negative 5 over 2 C1 minus 5, 3 over 2. 3 over 2 D1 equal to 0. And since D1 is equal to 0, you see that C1 again will be equal to 0. Okay. And then we move to the next one, this row. So from that row, we're going to have B1 plus C1 plus D1 equal to 1, right? So these are zeros already. C1 and D1 are zeros. So notice that B1 equal to 1. Okay. Finally, sorry, we have 2 more. For this here, this will be a 2 D naught, okay, because of that D naught minus C1, okay, because that's the position for, sorry, B1. That's the position for B1 is equal to negative 1. Okay, so 2 D naught is equal to negative 1 plus B1 is 1, right? So both this move side be positive. So from this, see that our D naught just be equal to 0 as well. Okay. All right. And then move to the last one. Last one contains B naught and D naught. So we have B naught plus D naught equal to positive 1. So D naught equal to 1, so B naught just equal to 1 as well. So we have this. So now we can write our spline. So S naught of X will be equal to A naught was equal to 0. Okay, B naught is 1. So 1 minus X. So we have X minus 1, sorry. Or X minus X naught, which is 0. Okay, X minus X naught, which is 0, plus C naught. Okay, so I'm trying to say here, I'm trying to write this spline for S naught. Remember that S naught is simply A0 plus B0, X minus X naught, plus C0, X minus X naught squared, plus D0, X minus X naught cubed. Okay, so if you plug in all the values we found, you see that under X naught is equal to 0, remember that. So what we have just be X. Okay, that is our S naught. X, just get the X. All these are zeros. You have A naught, C naught, D naught are zeros, and X naught again is equal to 0. So the values of X for this one are between what? 0 and 1. Okay, similarly for the S1 of X is equal to our A1 was equal to 1, and also found what? Our B1 also got to 1, meaning the rest also were zeros from what we calculated here. So our B1 is also equal to 1. The rest were zeros, so just have X minus X1, which is just 1. And this is between 1 and 2. Okay, so these are the 2 splines we're supposed to find. Okay, thank you so much for watching, and make sure that you subscribe to my YouTube channel. Thank you. May God bless you all.